Okay, hi folks. Alright, I'm starting my stopwatch this time. And we have just a handy dandy chart here to make sure that you remember vector quantities need to have a direction for every answer that you have that's a vector quantity. They are displacement, which we call delta x, velocity, v, acceleration, a, force, which is going to come in many different forms. Friction is considered a force. Anything F equals ma, and any weight is also a force. These all need directions. So for example, if I reported my weight as 200 newtons, which it's not, then I would have to say 200 newtons straight down toward the center of the earth, because its acceleration is down, so its force is also down. Scalar quantities such as distance, speed, and mass do not require you to report a direction with them. So just for the make sure when you take the test, you give me vectors having a direction. So practice problem number 1. A father is teaching his young daughter to ice skate by pulling her across the ice with a short rope. If the daughter, whose mass is 25 kilograms, I'm going to drop my pen. So I write down what I know. Mass is 25 kilograms. Starts to accelerate at 0.35 meters per second squared. What is the force that her father is using to pull her? Assume that the ice is frictionless. So if we drew our force diagram here, we've got dad and daughter with a downward force, ice with an opposing force. They cancel each other out, no big deal, right? And then we have them, him pulling her like that. We're assuming the ice is frictionless, so we won't have an opposite force, so we're just worried about this vector right here. We have mass, we have acceleration, we want to know about force. Clearly very easy, since we're only considering one thing. So we're going to multiply 25 kilograms by 0.35 meters per second squared. 0.35 meters per second squared. If you type that into your calculator and you keep your two significant figures because they both have 2, then you would get force is equal to 8.8 kilogram meter per second squared, which kilogram meter per second squared is really a newton. So same exact thing. Now remember, force is a vector, so it takes 88 newtons in the direction they're going, or in the direction he's pulling her of travel, maybe. But you have to give me some kind of direction because force is a vector to have a complete answer. So 8.8 newtons in the direction that they're going is the force with which he pulls her. Alright, new color. Let's see, number 2. A 501 pound rock. So is pound a force or a weight or a mass? Well, pounds are actually a weight. Is it 501? Pounds. Has fallen onto a frozen pond that you want to use as an ice skating rink. If you push the rock with a force of 16 pounds, how fast will the rock accelerate? And you can assume there's no friction between the rock and the ice. So I need to find out a mass, so I can use F equals ma. Well, I have a weight, how do I find mass? Well, I use W equals mg. So my weight, 501 pounds, equals mass times gravity, which we're assuming this pond's on Earth, not many other places where you'd have a frozen pond to skate on. So my mass is going to equal 501 divided by 9.8. Oh dear, I'm all messing up here. Well, I don't like this gravity because I'm in English units, pounds, so I really need 32 feet per second squared. So 501 divided by 32 will give us well, 16, two significant figures because of this, and then a pound, let's see, what do we have? Pound, I don't know. How have I messed up here? Weight equals, oh, I just need slugs. So this would give me, a pound is a slug foot per second squared. So the foot per second squared divided by foot per second squared will cancel that and give me a slug. 16 slugs would be my mass. So I'll erase my W equals mg stuff just so we can look at what the problem really is asking. Now that we've converted weight to mass, now we can find our force. And we know 16 pounds is what we're going to be able to push the rock with of force. Also, we know that we have no opposition due to friction because the ice is considered frictionless. And we also have our weight and the equal and opposite here, which cancel each other out, so we don't have to worry about them. So that's equal to mass, which we know to be, force. Oh, force is 16 pounds, mass is 16 slugs, times acceleration. I can't make an A. You know it's late, right? So my acceleration is going to be 16 pounds divided by 16 slugs. And since a pound is a slug foot per second squared, that's going to give me two significant figures, 1.0, feet per second squared, because the slugs are going to cancel out. And at pounds, if I just change the unit here, it would actually be slug times foot per second squared, because that is what a slug is. So when I divide through by the 16 slugs, my 16 slugs would cancel, leaving me with 1.0 foot per second squared. So this is my acceleration. I hope I'm right. Yes, yay, good. Okay, make sure you've done these problems before you listen to the solution so that if I am wrong, you can at least question me or yourself. Number 3, in problem 2, I asked you to assume there's no friction between the rock and the ice. You do have to assume there is friction between your feet, or shoes or whatever, and the ice. Why? Well, according to Newton's which law? So that would be Newton's third law. For every force, there's an equal and opposite force. You cannot apply a force to the rock without the rock actually applying a force to you. If there were no friction between your feet and the ice, you would push on the rock would push back on you, and both of you would go in equal and opposite directions infinitely until there was friction or some other force. So we have to assume that to be able to apply that force, your feet can stay still so that you can overcome the equal and opposite force the rock applies on you. So, yep, that's about it. Number 4, a rock has a mass of 523 grams. What is its weight in newtons? So, again, we'll use our good old equation, weight equals mass times gravity. What is its weight in newtons? Well, what is a newton? Let's consider that for a second. A newton is a kilogram meter per second squared. So we really want to convert to kilograms. So to convert grams to kilograms, we know there are 1,000 grams in a kilogram. So we could do 1 kilogram is 1,000 grams, cancel our grams, and we end up with 0.523 kilograms. So weight is equal to mass, which we're going to use 0.523 kilograms, times gravity. We want meters per second squared, so we use 9.8 meters per second squared. Our units then will be kilogram meter per second squared, which is a newton. So when I plug 0.523 times 9.8 into my calculator, keep two significant figures, I get 5.1 newtons. Now, is that going to be a complete answer? Well, no. 5.1 newtons is a force. A force is a vector quantity. So, since acceleration due to gravity is down, we'll go with down toward the center of the Earth. So weight, 5.1 newtons down. Let's see, how's my time coming? Oop, I'm going to stop and start again in a minute.